So looking at this function, this is a product rule. If I name this f and g, if I want to take the derivative of the first function, hold the bottom function, minus the derivative of the bottom, hold the top, all over the bottom squared. And that's what it looks like was done here. And you can kind of see the algebra, the derivative of the top, hold the bottom, minus the derivative of the bottom, hold the top, over the bottom squared. Simplifying, you get this function. Now we do the same thing for the second derivative. The derivative of the top function in this case is 2x plus 2. Hold the bottom, x plus 1 quantity squared, minus the derivative of the bottom. The derivative of the bottom is a chain rule, so it would be 2 times the quantity x plus 1 to the first power. If you're not at the chain rule part, you can extend this function or expand it to be x squared plus 2x plus 1, which when you take the derivative of that, you get 2x plus 2, which would be the same as 2 times the quantity x plus 1. So if you're not at the chain rule, that's fine. You would go ahead and expand it, and you could just take the derivative, and the derivative would be 2x plus 2, which is the same as this. So the derivative of the bottom, hold the top, x squared plus 2x minus 6, all over the bottom squared, x plus 1, quantity squared, so this would be to the 4th power. The benefit of using the chain rule here is you can see I can factor out an x plus 1 in both these terms, right? So just kind of highlight, this is one term, and this is another term. So I can factor out an x plus 1. Algebraically, it's going to make simplifying easier. So if I factor out an x plus 1 in both these terms, I have x plus 1, and then I have 2x plus 2 times x plus 1 minus 2 times the quantity x squared plus 2x minus 6, all over x plus 1 to the 4th power. And then that simplifies the x plus 1 in the numerator, and this would then be to the 3rd power. So then expanding out some things, 2x squared plus 2x plus 2x plus 2 minus 2x squared minus 4x plus 12. So be careful that you want to make sure you distribute this negative to all three terms there. So simplifying, see, we have a plus 2x, a plus 2x, and a minus 4x, so those are going to cancel. I have a 2x squared, minus 2x squared, those are going to cancel. So I end up with 14 in the numerator over the x plus 1 quantity cubed. So the algebra can get kind of ugly here, but it should all simplify to 14 in the numerator divided by the x plus 1 to the 3rd power in the denominator. If you have any questions on this, please let me know.